Now, in section 8.2, you're still solving systems of equations. You're just looking at a different method. So instead of having to graph everything, you can use the substitution method to solve the system of equations without constructing the graphs. Now, again, I went through several examples of this in my completed notes that I sent to you. The main thing that I wanted to mention to you here is that it does not matter which equation you start with. It does not matter which variable you solve for. The key is to make sure that whatever equation you use to solve for a variable, you plug that in to the other equation. So just to show you that it does not matter which way you go, I'm going to work through this one two different ways. Now, while it does not matter which equation you solve for the variable, there's usually one that's going to be easier than the other, and so that's the one that I would typically go for. So like if I were looking at this system of equations, what would jump out at me is that this y right here has a coefficient of 1. So it's pretty close already to being by itself. Therefore, that's going to be really easy for me to solve for y because all I would need to do is subtract the 7x from both sides. Now, the main thing again is for me to remember, if I'm going to solve that second equation for y, then I have to make sure that I plug it in to the other equation. So that other equation is 2x plus 2y is equal to 18. Now, I just solved that second equation for y. So right here, I'm going to plug in that entire statement for y. Right, so right here where the y is, I'm going to come right back up here and say, all right, I just determined that y is negative 7x plus 9. Now, always use parentheses when you're substituting into the other equation because you are going to have to distribute that too. So now, when I simplify, distribute that 2, I'm going to have negative 14x plus 18, and then of course on the other side of my equals is an 18 as well. So now notice what happens. When you substitute, you end up with just one variable. And when you have just one variable, you're able to solve it using just one equation. So 2x minus 14x, that's negative 12x, just combining like terms. And then a basic linear equation, I just want to get x by itself, get everything else on the other side. So I'm going to subtract 18 from both sides. That's going to give me negative 12x is equal to 0. And then to get x by itself, I'm going to divide both sides by that coefficient. And that's going to tell me that x is equal to 0. Now, that's only half of my solution, right? A system of equations, you need a solution for x and you need a solution for y. And that's why it typically says to write your answer as an ordered pair. But once I solve for one of those variables, all I have to do is remind myself that right up here in the beginning of the problem, I solved this for y. So now that I've found the value of x, all I have to do is remember that y is negative 7x plus 9. So if I just determine that x is equal to 0, I can plug that in right here, and I can determine that y would be equal to 9. So my solution here is the ordered pair. X always comes first in an ordered pair. My solution is the ordered pair 0, 9. When x is 0, y is 9, this system of equations will be true. So I come down here, this has one solution. I showed you the special cases, the no solution, and the infinite number of solutions in my notes. But this has one solution. X is 0, y is 9, and that's all I have to do. Now again, the main thing is to realize you did not have to work it that exact same way. All right, no matter which one you choose to solve for and which one you plug into the other equation, you're going to get the same solution as long as you follow the right steps. All right, so let's just look at that here just to see All right, let's say when you approached this problem, you did not decide to solve that second equation for y. All right, let's just say, for example, you decided you were going to take the first equation and solve it for x. Because again, it doesn't even matter what you solve for. It's not like with graphing where it has to solve for y. You can solve for whichever one. So if I were going to solve that for x, I would start by subtracting 2y from both sides. And then I would have to divide everything by 2. So this would become negative y plus 9. Again, just solving for x, right? Getting x by itself. And then again, the big thing for you to remember is if you're going to take that first equation and solve it for one of the variables, you have to plug it into the other equation. So the other equation, 7x plus y, is equal to 9. All right, well, I just said that x, and again, I'm going to use parentheses, is negative y plus 9. That's what I determined right there. And so if I plug that into my second equation for x, right, and then I simplify, distribute that 7, negative 7y plus 63 plus y is equal to 9. Now I've got an equation with just one variable, right? This one happens to be y, but I'm able to solve. So negative 7y plus y is negative 6y plus 63 is equal to 9. And now, to solve this one for y, because that's my variable I'm looking at here, I would subtract 63, because I just want to get y by itself from both sides. That would have negative 6y is equal to negative 54. I would divide both sides by negative 6. And that would tell me that y is equal to 9. So notice, working through it this way, it means I solve for y first instead of x first, but that doesn't matter because I got the same solution for y here that I did when I worked it the other way. And then again, this is only half of my solution. So I want to make sure that I end up with a solution for x and a solution for y. But once I solve for one, I just go right back up here to the beginning, and I remind myself that x is equal to negative y plus 9. And so if I plug in the value of x, or not the value of y that I just found at 9, then when I evaluate this, I see that x is equal to 0, and my ordered pair, my solution, once again I see, is the ordered pair of 0, 9. So again, the main thing I want to show you here is you have some flexibility in how you solve these things, as long as you make sure that you take one equation, solve it for one variable, and plug it into the other equation. You get to choose which equation you start with, which variable you solve with, so take the one that's going to be the easiest for you to work with and use that to get you started.